Alrighty, so yesterday we started talking about quadratic equations. So you got this sheet from me, and we talked about the different pieces of a parabola. So the x-intercepts, the y-intercepts, all that kind of good stuff. Today we're going to be looking at how to deal with graphing, specifically in that vertex form, that first form on our list. So if you flip the sheet over, you should see this. So vertex form is just a form of an equation where it has y equals a x minus h squared plus k. I'm hoping these three letters look very familiar to us. So we're going to be kind of talking about how do we find each of those different pieces when we're dealing with a vertex form parabola. So the nice part is that that vertex is exactly what we're given in the equation. It's always going to be at h comma k, no matter what. So if I give you an equation that looks like this, where it's y equals 2x minus 3 squared plus 5, my vertex for this equation would be at 3, 3, 5. So hk every time. Notice here it looks like a negative 3. It's actually a positive 3. Our domain will stay all real numbers, just as it always is. And our range will always go from whatever the k value is to positive or negative infinity. And this piece will always be based on the a value. So if a here is positive, then it'll be a positive infinity. If a is negative, then it's a negative infinity. X-intercepts are always going to be a little difficult to find here. Not impossible. And they won't always be nice numbers. So you'll have to solve to find them. Now with any other y-intercept, just like we're used to, the y-intercept is always on the y-axis, which means that the x value is 0. So all you're going to have to do is plug in the x value of 0 into your equation right here, and you'll get out a y value. There is a formula for finding it using vertex form. It's not worth memorizing. Your axis of symmetry, AOS, will always be at x equals h. So I just want to highlight a couple of things in there for you. So first of all, notice once you get that vertex, this is kind of like the golden ticket in this case, because it gives you the axis of symmetry here, because it'll always match. Those two numbers will always match. It gives you part of your range, because those numbers, again, will always match. And you already have your domain and your y-intercept. So really, the only piece of this graph that you won't really get from your axis or from your vertex is your x-intercepts, which you have to solve for. So let's go into graphing a little bit. First things first that we always want to find is our vertex. No matter what, that should be the very first thing you look for. So your vertex, in this case, should be at 3, 2. Now when I graph these, I always like to graph using our vertex as the middle point, because we know that from our notes from day 1 here, that the graph is a perfect mirror across the AOS, meaning that that vertex is exactly in the middle of my mirroring. So by putting it in the middle of my table, that means whatever I get over here and whatever I get over here should be exactly the same. So from there, I always pick x values that are the same distance away from the vertex. So from 3 to 2 and from 3 to 4 is the same distance. And then from 3 to 1 and 3 to 5 is the same distance. You don't have to do it that way, but I just find it to be a lot easier if I do. So then we can plug those values in. So I plug each one into my equation, and I'll do a couple of them off to the side so you can see what that looks like. So 1 minus 3 squared plus 2. So following our order of operations, PEMDAS, the first thing I need to do is inside the parentheses, 1 minus 3. So I get negative 2 squared plus 2. Now, any number squared is automatically a positive. So even though this has a negative, it does end up going away because it's inside the parentheses. So negative 2 times negative 2 is 4 plus 2, which gives me 6. Now, like we said, these are perfect mirrors of each other. So theoretically, if I did this correctly, the number I get for 5 and the number I get for 1 should be the same. So I'm just going to test that just to be sure. 5 minus 3 squared plus 2, which gives me 2 squared plus 2, which is 4 plus 2, which is 6. So I did get the same thing. then that should also be true here to here, from 4 to 2. So if I plug those in, 2 minus 3 squared plus 2, I get negative 1 squared plus 2, which is 1, plus 2, which gives me 3. And if I were to plug in 4, I would get the same thing. Once I've got my 5 points, I am ready to graph. So 3, 2 is the vertex. Now, when you graph these, you don't want it to be straight lines, because it's not a straight line, it's kind of a U shape. So make sure to give it a little bit of a U shape there. So again, we started with our vertex. That always goes in the middle of my table. Then I went out an equal distance in either direction from it to get 2 more points, and I plug them in, and I graph them. So let's try it again. So first thing I find is my vertex. So you should be finding the vertex before I write it down, just so you know that you've got it figured out. So according to this, my vertex should be at negative 4, 2. So that's going to go in the middle. From here, I need to find coordinates that are the same distance away. Hopefully you're finding those on your own already. So I'm going to pick negative 3 and negative 5 because they're both 1 unit away from negative 4, and negative 2 and negative 6 for the same reason. They're 2 units away. Because I did it that way, I should be able to get the same same y values here and there. So I plug them in off to the side. Again, following that order of operations, I'm going to plug in negative 2 plus 4 squared plus 2. So I get 2 squared plus 2. So 2 squared is 4, so it's 1/2 times 4 plus 2. And a final answer of 4. If I plug in negative 6, I also get 4. I'm going to do the same thing with the negative 3 and 5. So negative 3 plus 4 squared plus 2. I get 1. Which gives me 1/2 plus 2, which is 2.5. 2.5. I can go through and graph my points. I always like to start by graphing the middle because that reminds me that that's the point where it should be symmetrical around. And if it's not, then I know I messed something up. So here we're at 2.5. There we're at 2.5. Negative 2, we're up at 4. At 6, we're up at 4. And yep, that looks pretty symmetrical to me. Now, as you go through these types of problems, you're going to be asked to find all the key features. So all of those different things that we've talked about. So, like I said, we always start with our vertex. So the very first thing I should be writing down is negative 1, 3 for my vertex. Now remember, that's HK, which gives us our axis of symmetry. It gives us part of our range. We already know what our domain is because it's always the same. And then it's just a question of finding these 3 pieces in the middle. So axis of symmetry should be at x equals negative 1. Range is going to go from 3. And then the question comes, is it going to go to positive infinity or negative infinity based on my a value? So my a value is a negative, which means that my range is going to go down to negative infinity, and it's going to go up and stop at 3. If you wrote that the other way around, technically you're still correct. It's just kind of like bad grammar in math. So you can do that, but it's not a very good way to write it. So I would prefer this way. All right, y-intercept. Well, I suppose let's make our table first. We'll go back to the y-intercept. So I have negative 1, negative 2, negative 3, 0, 1. I'm going to plug in my positive numbers this time because the negatives are a little bit more difficult for me to work with. So I prefer to plug those in if I get a choice. If I plug in 0, negative 3, 0 plus 1 is 1 squared. So I get 1 squared, which is 1 times negative 3. So negative 3, which gives me 0. So here and here, I'm going to have a 0. And I'll plug in 0 as my next, or that was me plugging in 0. That was silly of me, because that's why we should always write out all our steps. Because otherwise you'll make mistakes like I do. -3, 1 plus 1 squared plus 3. 1 plus 1 is 2, squared is 4. So I get -12 plus 3, which is -9. Now, conveniently, by doing that, what I've already found is my y-intercept. Remember, we're looking for where the graph crosses the x-axis, the y-axis, which is where x is 0. I've also conveniently found my two x-intercepts. So when I graph, I don't have to worry as much about finding all those different pieces because they'll actually come from my table. That's why it's always a good idea to start with your table. Sometimes you'll come across things that might be handy. So -1, 3 would be there. Those two, -3, -9, and 1, -9. Again, we try and make it curved. It's a little bit harder when it's stretched out like this, but that's all right. Oof, that is a rough line. Okay, so our y-intercept is at 0, 0. Our x-intercepts are at 0, 0, and -2, 0. So like we said, you can have 0, 1, or 2 x-intercepts. In this case, we have 2. And in this case, the y-intercept matches. Sometimes that happens, and that's okay. Concavity. Remember, concavity is whether the graph is curved up or curved down. So concave up, concave down. So this case would be concave down. All right, so we've gone through a couple of these, just some practice problems. So you've got a few ideas of how to do this. So when we graph, we always start with our vertex, go out 2 points in either direction, plug them in, and plot. And remember, we find all of these different pieces from finding our vertex. Once I have my vertex, I can find my axis of symmetry, I can find my range, domain is always the same, and then I can just find these 3 pieces through the middle. So you've got 3 problems here that I'm going to have you try, or I'm sorry, not 3 problems, 2 problems here that I'm going to have you try, and then you can come back and compare.